Functions, 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 and vocab. In Algebra 2, we focus on more complex functions than you learned in Algebra 1. For example, a log function in red and a trig function in blue. Some more common functions that you would have seen in Algebra 1 would be some sort of linear function, straight line, or some sort of quadratic U-shaped curves or parabolas. The key question is, well, what is a function? You have a little bit of knowledge, but our learning targets for today is to state the domain and range of a relation, determine if said relation is a function, and evaluate given function notation. In Algebra 1, we spent a lot of time making tables, and we would view them like a machine. For example, I have some input values that we're going to put into the machine. Okay. Inside the machine, there's some sort of function rule. For example, 2x plus 1 would be our function rule, and we would get a series of output values. Let's consider the input of 1. If I put 1 in for x, 2 times 1 plus 1 gives me an output of 3. So my output values are directly related to the input values. A relation is a set of ordered pairs with a domain, or x values, and range, or our y values. A function is a special relation where each value in the domain is paired with exactly one range value. Only one has to be one. For example, for each, we want to state the domain and range of the relation and determine if it is a function. Look at the following table. The domain is the inputs, 0, 1, 2, 3, and the range is my output. The domain is mapped to the range. Each input has one output value, so it is a function. Consider the following mapping diagram. The domain is the inputs. The range is my outputs. Each value in the domain, again, has exactly one output. So this is a function. Some of us may be curious about the value c, but that's in the range. That's okay to be repeated. Okay, the domain has exactly one value in the range. Okay, for our last mapping, okay, look at -8. -8 has two outputs, so this guy is not a function. Now, what if the points are already graphed? We can use the vertical line test. A relation is a function if a vertical line drawn through its graph passes through only one point. Take a pencil and move it from left to right. If it crosses more than one point, it's not a function. Consider the following graph. If we put our pencil on the graph and slide from left to right, if at any point we're touching 2, it is not a function. Next example, again, taking our pencil, sliding from left to right, one output, again one output. So this is a function. It passes the vertical line test. Is this a function? Using the vertical line test, sliding from left to right, there are points that touch the vertical line once. However, if there is anywhere that touches the vertical line twice, it fails the vertical line test. So this is not a function. Function notation. Often, the function rules are written as y equals. The y is replaced with the name for the function. F is the name of this function. The x is the input value. This is the mathematical rule for the function, 3x plus 4. If I want to say this out loud, I would say the value of f at x, or f of x. That's what you'll hear more often. Evaluating a function rule. For example, f of x equals negative 3x plus 7. We want to evaluate this for the value x equals 2. So, where I see an x, I am inputting a negative 2. F of negative 2 equals negative 3 times negative 2 plus 7. Negative 3 times negative 2 is 6. Bringing down my plus 7, I get 13. So f of negative 2, which is my x value, equals 13, which is my y value. If I wanted to write this as an ordered pair, negative 2, comma 13. So I could graph a series of points and get a picture that way. Again, we want to evaluate g of x when x is negative 2 as well. So where I see an x, I'm going to input a negative 2. So putting in a negative 2 anywhere I see an x would give me the following. And I'm going to evaluate. Okay, I'm going to do my exponents. Negative 2 times negative 2 gives me 4. 2 times a negative 2 would be negative 4 and minus 10. 4 minus 4 is 0. Minus 10 gives me negative 10. So my ordered pair here would be negative 2, negative 10. Other ways you'll see this written would be find f of negative 4. That's asking the same thing. F of negative 4 would be negative 3 times negative 4 plus 7. Well, 3 times 4 would be 12 plus 7, and I get 19. So my output for the input of negative 4 would be 19. And I want you guys to do B as an exercise on your own.